Hello folks, so I basically wrote out the solution, but I want to walk you guys through like what we're learning. We kind of talked about the same idea from last class. So let's look at some of the ideas. So here's your original power series, how it looks like. Y equals summation of c sub n x raised to the n starting from 0 through infinity. And you can actually come up with this. We talked about the first derivative. What happens, the index gets shifted. That's why you're starting at n equals 1, and the reason when n equals 1 is because the first term, if you write out a couple of terms here, then the first term is going to look like c sub 0 x to the 0, which is 1. Then the next term would have looked like c sub 1 x, then c sub 2 x squared, and so on. And if we take the second derivative, so if you take the first derivative, this term is gone, your index is moving. If you take the second, so on the first derivative, you're going to have something like this: c sub 1 plus 2 c sub 2 x plus so on. Then when you take the second derivative, this term goes to 0 as well. That's why now you're starting at n equals 2. So remember, if you have it in this form, then your n equals starting at 2. In last class, what we looked at, I already gave you the series with the index in here, so that's why it went in a different route. So but this is always the general form. You should have this guy in your note card. So y1 first derivative and the second derivative. So the question is, find two power series solutions of the second order y double prime plus 4xy prime minus 2y equals 0 about the ordinary point x equals 0. So how the idea works is the same thing what we have been doing. So y double prime gets replaced by this right here. So here's your y double prime plus 4 is that quantity, times x times y prime, the first order derivative, which is here, minus 2 times, this is just my y. Once you have all of this form, all you have to do is the same properties that what we talked about last class. Is one of the first thing is the exponents of x needs to be the same and the index must start at the same place. So if you really look at this is really telling you the first one's index is starting at 2. So if you write out, so you're having x raised to the 2 minus 2, which is x raised to the 0. How, like this would give you x raised to the 0. However, if you start over here, you can't really start at the beginning because you got an x outside. So what we do is we're going to put it inside here. So this is where is that x to the 1 in here, and there is a minus 1. So basically that makes it x to the just a n. Over here, if you start here, your first term would be x to the 0 as well. However, if you start here after you simplify it, like you know how we said this is x to the 0, this is x to the 0. However, if we put n equals 1, that's really x to the 1. So we need to somehow get rid of that x to the 0 term. Remember, whenever that issue, what we do is we take care of that term by writing out that first term out. So when n equals 2, you're going to have c sub 2 times 2 times 2 minus 1, which is c sub 2 times 2 times 2 minus 1 x to the 0, which is really 2c2. So that's 2c2 here. Same thing here. So as I already took 2, then I should start at 3, and everything else remains the same. This chunk remains the same here. Same here. Over here, I need to get rid of that x to the 0 term, and which is basically when you put n equals 0 here, you're going to have negative 2 c sub 0 x to the 0, which is that minus 2. As I already used 0, now I have 1. Now as we have to match the index, so we take k equals n minus 2 here, k equals n, you're not doing anything here, and then you're saying k equals n here. So that statement is let k be the new index where k starts at k equals 1. So here you go, we're starting at k equals 1, k equals 1, k equals 1. Everything else still stays the same. All we're doing is if k is equaling to n minus 2, meaning n should be k plus 2. So wherever we see n, we substitute k plus 2 there, and then we wrote out this state equation. And once we have that, we basically combine the green ones because those are the constants, and then we factor out, because now we have the same index and the same exponents. We can actually factor it out, which I would do on the next step. So by the identity property, if you're solving this, so you're saying this guy, you can factor out a 2, setting it equal to 0, so you're saying C2 is the same thing as C0. And if you set all of this chunk equal to 0, which is all of this equal to 0, you can solve for C sub k plus 2. And what I did is I basically moved it on the other side. If you move it on the other side, you have a negative multiple. Instead of writing negative 2k plus 1, I'm just swapping them. So I wrote 1 minus 2k. And you can solve for C sub k plus 1, which is a let me zoom out, which is a recursion relation here. So what this is telling you is I can always get information when I put k equals something, then I get the next one. When I put k equals 1, I'll get 3, and so on. My system froze, so let's see. Okay, so it's back. So here's the recursion relation. What we do is from here, we start taking values of k. So if you take k equals 1, you'd have C3. And then you get like an expression like negative C1 over 3. When k equals 2, if you put 2 here, so you'd have C4. Then you'd have C2 here. And it looks like negative C2 over 2. But remember, C2, we said C2 is the same thing as saying right here, if you look at it, C2 is this, you're saying C2 is the same thing as C0. So you're just putting it C0. So we're going to represent everything in terms of C0 or C1. So you build up K3, K4. So for example, when you do K3, you have negative 1/2 C3. But remember, C3, this guy was really negative 1/3 C1. So if you put that, that becomes positive 1/6 C1. And you start solving for k's and so on. And once you do all of that, you get a position where you have all of those k's with the corresponding c's. So everything is represented in terms of C0 and C1. Once you have that, remember recall our equation was like y equals summation from 0 through infinity of c sub nx to the n. If you expand this looks like this. So what we do is we start gathering, well, remember C2 is the same thing as C1, or I think it was same thing as C2 was the same thing as C0. So we're now plugging in the value of C2 as C0 x squared. So everything is C0 or C1, C0 or C1. Everything gets replaced by C0 or C1 here. And then what we do is basically we group the terms that have C sub 0 and we group the terms that have C sub 1, so that our general equation looks like y equals C sub 0 y1 of x plus C1 y2 of x. So here's 0 y1 of x. All of these ones, 1 plus x squared minus half x squared, all of these guys are your C0 terms. So if you look at this guy, then this is that other guy, negative 1/2 x to the 4th and so on. And y2 of x is all of my C1 terms. And it really doesn't matter which one you pick, because these are just two equations. So I'm going to go ahead and upload this and then with the video. So hopefully that helps. I'll see you guys next time.